In this segment, I want to talk through some strategies for getting started when you're maybe stuck trying to solve a problem. You're faced with a blank screen. How on earth do you write this function you've been asked to write? So I want to give you some help here, some questions to ask that can help you get started or help you get moving with solving a problem. Now, the examples I'm looking at here are quite simple, but the ideas here are usable right the way through the course. So I'd recommend you, if you are getting stuck a bit later on in the course, come back to this video and see if you can get some help by watching it. So often people say, where do I begin? I've got a blank piece of paper. I've got a blank screen in front of me. How do I get started writing the function I've been asked to write? And one question it's always worth clarifying is, what actually am I being asked to do? And in this segment, I'm going to use examples to illustrate the idea so it's not too abstract. So suppose you're asked to write a function that returns the middle of three integers. Well, it's clear if you're given 4 and 2 and 5, the middle of those is number 4. But what do you do if the numbers are 4 and 2 and 4? Well, a situation like this where what you're being asked to do isn't completely specified, there are really two things you can do. One is to clarify. You can ask the person who's getting you to solve the problem to say what you should do in that situation, or you should be very clear yourself by writing comments in your solution to say what it is you are doing, how you're dealing with this ambiguity that has come up in this particular question. So either get more clarification or be clear that you have clarified the problem in a particular way. And you can see here that I've come to this understanding that the problem isn't quite as clear as it should be by looking at some examples. And I'd always recommend you, if you want to understand what a specification means, what a task means, think about what it means in the case of some examples. And you'll see me doing this as we go through the course again and again. And finally, just one thing to say. You've spotted this problem perhaps before you start programming, but it's often the case that once you start programming, you will discover where there are holes or ambiguities or incompleteness in the task you've been asked to solve, in the specification. So in that sense, programming keeps you honest. Programming forces you to think about those cases that are perhaps not so clear in what you're being asked to do. So summarizing what I'm saying here is, if you can get clarification from the person who's asking you to solve a particular problem, do. Otherwise, you be clear about how you have clarified it yourself. Okay, one particular way of clarifying in the case of Haskell, clarifying the problem, is to say, what is the type of the function I'm trying to write? Now, it's pretty clear in the case of the previous task we had, write a function that returns the middle of three integers. It will be a function perhaps called middle of 3 that takes 3 integers and returns an integer, and that's the type that I've written here. Now it could be that the way the ambiguity about when two numbers are the same, in the case where you give it 4 and 2 and 4, you could say in that situation there isn't a middle number. So one alternative way that you might write the type is to say that you return an optional integer. You return an integer perhaps, or perhaps you return nothing. Now that's something I'll come back to. It's a pattern we use often in functional programming. It's called the maybe type, but I'll come back to that in a few sessions time. So a particular way of clarifying a specification, a really helpful question to ask yourself is, can I work out the type of what it is that I'm trying to write? If you can't do that, then it's going to be very difficult to continue solving the problem. Getting the type right first is often the key to making further progress. What else can we do? Well, a really important question to ask yourself when you're trying to solve a problem is, what do I know already? Okay, you're starting from a blank sheet of paper, perhaps a blank screen, but there are some other things that you know, other functions you've seen, other functions you've used, and it's important to think about the ways that they can help in solving the problem at hand. And just to look at a very concrete example, it's something that we've come across before, but it's a simple example. I wanted to use it, but it's also an example which illustrates a mechanism that gets used again and again. Now, suppose I know a function that gives me the maximum of 2 integers, and somebody is saying, please write a function that returns the maximum of 3. Now, we can use this function max in 2 ways, and it's crucial to understand that. The first way is to say, can I use this definition as a model of what I need to write here? So I know here's a solution for working out the maximum of x and y. How can I expand that to give the maximum of 3 numbers, x and y and z? And you can see the way max is written. First of all, you've got a condition. If x is bigger than or equal y, that's the case in which x is the maximum. Otherwise, y is the maximum. Now, how does that carry over to the case where there are 3 integers, x and y and z? Well, here you can see I've taken the definition of max, I've renamed it max t for maximum of 3, and added an argument z, and I've changed the definition. I've said, what's the condition for x to be the maximum? It's that x is bigger than or equal y and x is bigger than or equal z. So that makes sure that x is bigger than the other 2 or bigger than or equal the other 2. And so the answer there is x. And then I have to think, what if the answer isn't x? We know if x isn't the biggest, then it's going to be y or it's going to be z. So then we have to check, in that case, going to the second guard, if y is, in that case, where x is not the biggest, if y is bigger or equal z, the answer is z. The answer is y, I'm sorry. Otherwise, the answer is z. So we've used the same sort of logic in defining max t, work out the condition for something to be the answer, and then deliver that answer if the condition is met in defining max t as we did in defining max. So we took a definition and we modified it. We took it as a model for what the answer should look like. And that's often how we think. We start with something we understand and we modify it into the thing we're trying to produce. Now, there's a crucial alternative to using the function as a model, and that is simply to use the function that we've got in defining the new function. And I think I did talk about this before, but it's so important. I think I want to emphasize it again. So perfectly well, think about it as a model, but think, can I actually use this? What functions do I know already I can use? And in this case of the maximum of 3, we've got the maximum of 2, we can define the maximum of 3 this way. We can first take the maximum of x and y, and then take the maximum of that and z, and there's our answer. I've written it here, writing the functions as ordinary functions, applying them with the arguments afterwards. You can write it in this way, where we turn the function into an infix operation. So we take x, max y, and then the max of that and z. I just emphasize, I was asked in a question session about this. There's never any need for you to use this kind of do-it-yourself infix notation. It's always okay to write it as a simple function application. It's there in Haskell because some people find it more readable to write things in the infix form like this, but there's no need for you to use that unless you want to. But it's useful to be aware of it because people do use this style quite frequently. Now, I guess the general problem solving approach, and it's one that's applicable in all sorts of different cases, is to ask the question, can I break the problem down into simpler steps? And here let's think of an example. To write a function that returns the middle of 3 integers. Now, how can I think of solving that in smaller steps? One concrete way of doing that is to imagine you have functions that will help you. And then you can split the problem into 2 halves. First, you solve the problem using those functions, and then you follow up by defining those functions for yourself. Let me give you a concrete illustration of that in this case of the middle of 3 integers. And let's take again, we're using the definition of max t as a model. How do I define max t? Well, I write the condition for x to be the maximum, that is x is bigger than or equal y, bigger or equal z, and when that guard is true, I return x. So I can think of defining the middle function in a similar way. I can say middle of x, y, and z is when x is in the middle, the answer is x. When y is in the middle, the answer is y. Otherwise, the answer is z. So then I have to, you could say that's a bit of a truism, but then I can say I can turn that x is in the middle into a function. And here I say is middle y, z, y, x, z. So it's saying x is in the middle of y and z. And similarly, I can say the answer is y when y is the middle of x and z. So then it's an exercise for us to define is middle for ourselves. So I've not solved the problem completely, but I've changed solving the whole problem into the problem of defining this is middle function. And I leave that to you to think about. X will be in the middle of y and z if y is smaller, less than or equal x, and x is less than or equal z, or it's between z and y the other way. So z is less than or equal x and x is less than or equal y. So you need to write that down as the value of a Boolean valued function. So there's an outline of how to do it, and as an exercise for yourself, why not try to write that down? Okay. So what I was trying to do in this segment was help you in situations where you didn't quite know how to begin solving a problem. And I suggested there are a number of questions that we should ask ourselves. Clarify what precisely you're being asked to do. In particular, what's the type of if you're being asked to write a function, what's the type of that function? What do I know already? And how can I use it? And I showed 2 ways that you might use it. One is to use a definition as a template, if you like, and modify that. Use that as a guide to writing a new function. And the other is to use functions you've already got, assembling those in different ways. And then finally, approaches, thinking about trying to solve the problem in smaller steps. And in the next segment, I look at what are called local definitions, which is a particularly useful way of breaking a problem down into simpler steps. So we'll be looking at a particular construct in Haskell, or constructs that allow us to do this breaking down a problem into simpler steps.